All right, so today we are going to do a really quick recording of what we did on Wednesday, October 7th. Today was an interactive class, so I didn't want to record because I had popsicle sticks were back. You're sad you missed it. But I wanted to make sure that students felt that they could share and talk and weren't going to be recorded. So this is a very quick breakdown of what we did. You're going to need to pause the program as we go along and making sure that you have the same experience we had in class. So the first thing we did was we talked about the quiz on Friday. The quiz on Friday is going to be all about matter notes 1 and 2. So we're talking about pure substances, mixtures, compounds, elements, heterogeneous, homogeneous, and then physical chemical properties, physical chemical changes, and intensive and extensive properties as well. Cohort A that's in school will take it in class, and you guys at home will take it between 7:30 and 1:30. So with that said, you will be seeing stuff on the quiz where I will have pictures that you have to identify. There might be concept maps you have to fill in. So it is 8 questions and 28 points. So hopefully you guys are prepared for that after today. And today is going to give you a few more examples of the types of questions you will see on the test or on the quiz on Friday. Our test is next Thursday on the 14th. Where's the 15th? The 15th, next Thursday. So what we did next was there is a worksheet in your packet called Matter Unit Worksheet number 1. So if you don't have that, pause the program here and run and get that. You will need this worksheet. If you don't have it, you can just write down these examples as you go along once you pause the program. And so we did a really quick refresher. Remember that matter is broken down into 2 main categories. We have pure substances where there's only one type of substance in your sample. And that breaks down into elements, which are a single kind of atom. They are found on the periodic table, and they are the basic building blocks of matter. The other type of pure substances are called compounds, and that's when you take one or more elements and you chemically join them together, and they're in a fixed ratio. Okay. Then if you have more than one kind of matter together but not chemically joined, that's called a mixture. And there are 2 types of mixtures. Homogeneous mixtures are where it's an even mixture. It's nice and evenly spread out and you cannot see the pieces and parts. And heterogeneous is where you can see the pieces and parts of the individual components of the mixture. So what I want you to do first is I put the music on quietly for about 5 minutes, probably was like 4 because they went quick. And I want you to go through and out of each of these examples of matter, I would like for you to tell me if they're an element, compound, homogeneous, or heterogeneous mixture. And you want to give each one a try. Don't skip any because I'm not grading it. But some of them can be rather tricky and some of them can be debatable, if you will. So pause the program now and answer if you think each of these are an element, compound, homogeneous, or heterogeneous mixture. All right. Hopefully you paused it and gave it a try. Don't shortchange yourself here. And let's talk about these. Sugar, C6H12O6. Does anybody know what that is? I'm like lecturing like this is a class. Hopefully you wrote down that this is a compound. Okay, it has carbon, hydrogen, and oxygen in a very specific ratio, and everything in sugar is the same thing. How about Coca-Cola? Did you put element? Right. It is not an element, and it's not a compound. Hopefully you at least said that Coca-Cola was a mixture. Now we had a nice, healthy debate in class over whether students just saw brown liquid, or maybe they saw brown liquid with bubbles in it. Or maybe they saw, brown liquid with ice in it. So it depends on how you support yourself and if you understand the definition of homogeneous and heterogeneous. If you just saw brown liquid and you said it was a homogeneous mixture, you're doing great. If you saw in your mind's eye a heterogeneous mixture because you saw the bubbles and all that stuff, that was heterogeneous. If you saw ice in it, a straw, things like that, that's also heterogeneous. So the big thing on some of these is you have to be able to support yourself in your answer, showing me that you understand the difference between the 2. Carbon is not up for debate. Carbon is an element. How about Kool-Aid mix? Again, some students were like, well, you know what I saw just red liquid. You hopefully would know that this is a mixture. It's not an element. It's It's not a compound. If you just saw a red liquid, you probably said it was a homogeneous mixture. But then some people said, well, I saw the powder because it said Kool-Aid mix. So is it the sugar-free powder where there's nothing in it except for just the flavoring? Or is it the sugared powder where you can actually see the different granules between the sugar and the flavoring and all that stuff? So again, if you can see the pieces and parts, it's heterogeneous. And if you can't, it is homogeneous. Okay, awesome. So as long as you supported yourself, it should be fine. How about a tomato? We had another lovely conversation about that. Obviously, hopefully, you know that tomato is not an element. It's not a compound. It's lots of things in tomatoes. If you saw a tomato with flesh and seeds and skin in all the different pieces and parts, that's a heterogeneous mixture. If you just saw a red homogeneous mixture, that is what you would have seen on that one. So I'm going to skip tap water to the very end because the tap water is one of my favorites. So we'll make sure. Aluminum is an element, and I had a whole bunch of manipulatives, I guess, that I could hold up for you guys. Aluminum, Al, nothing but good old aluminum in here. Salt water. We also had a good conversation about, there's my salt water. Okay, salt water, if you could see excess salt on the bottom, because a lot of people want to say it's homogeneous, for the most part it is, but if you had excess salt on the bottom, so it depends on what type of salt water you're looking at. Ammonium is NH3. That is a compound. Strawberry jam. What's the difference between a jam and a jelly and a preserve? So again, if you saw jam that has chunks in it, that's a heterogeneous mixture. If you just saw a red gelatinous substance, that would be a homogeneous mixture. Magnesium, Mg, right off the periodic table, is an element. Then we talked about tap water versus distilled water. And I kind of gave this away because of lecture yesterday, but tap water has water in it, but it also has other things. It might have iron from the pipes. It might have some salt in it. It might have some fluoride for your teeth. It might have some chlorine to clean it. It might have little living like microbes in it. That's like a living amoeba. I don't know. I'm not a biology person. It might have some minerals in it. It has possibly calcium and different things. So this is a mixture. And hopefully the water that comes out of your tap is a homogeneous mixture. If it's not, you might want to get a filter. But then distilled water is nothing but H2O. So what would distilled water be? Good. Distilled water is a compound. This is a pure substance. Nothing but H2O in here. Very important. I love to put that one on the test just so you're aware. If it was me, I would highlight that bad boy. Perfect. Then we reminded ourselves of what chemical and physical properties are, chemical and physical changes. In a physical change, nothing new is formed. Okay, you tricky ones that people get caught up on are state changes, excuse me, and dissolving. When you melt, when you freeze, when you boil, any of that stuff, it is a physical change, and dissolving is also a physical change. Chemical changes are when you make a new substance and it happens on a molecular level and you cannot reverse it. And some pieces of evidence that we talked about yesterday was if you made a gas, or if you change the temperature on its own, or if something disappears, or if there's a color change, odor change, or a solid is produced, that is a piece of evidence that you're having a chemical change. So what I want you to do is I want for you to pause the program, and I'd like for you to try to answer if you think of each of these things are a chemical or a physical change. All right, hopefully you went ahead and paused it. You want to give it a try to make sure you know, because you will see this on the quiz on Friday. Frying a hamburger. Well, let's see. Evidence. Do you have a gas produced, color change, odor change, all that kind of good stuff? That is a chemical change. Dissolving lemonade mix. If it says dissolving anything, you know that that's a physical change. Tearing a sheet of paper is a physical change. Ice melting, still water, it's a physical change. Crushing an aspirin tablet is also a physical change. Baking a cake, new odor, solid formed, color change, can't undo it. You can't get your egg back from a cake once you bake it. Lighting a match is a chemical change, and cutting a carrot in half is a physical change. Then we spent a little bit of time, as I have answers on here, yikes, talking about intensive and extensive properties. An intensive property doesn't matter how much you have. So when you look at this portion of the worksheet, I want you to look at the property and I want you to say, if I had 1 penny versus 10 pennies, would that property change? If it does not change, that means it's an intensive property. If it does change, that's an extensive property. So again, I gave them a few minutes and told them to try to just write, you can write IN or EX, and I want you to tell me if each of these are an intensive or an extensive property. Perfect. Mass. The first one. If I had 1 penny versus 10 pennies, would it have more mass? And the answer is yes. So this is extensive. Color. If I had 1 penny versus 10 pennies, would the color change? You would probably say no. And so we're going to go with intensive. Odor. If I had 1 penny versus 10 pennies, I guess pennies don't smell. So 1 flower, 1 rose versus 10 roses. Do they smell different? Probably not. Flammability is intensive. Okay. It doesn't necessarily depend on how much you have, but volume is different. If I had 1 ping pong ball versus 10 ping pong balls, do I have a different amount of volume? And absolutely, that is extensive. Density is probably one of my favorites. We lectured this, and you know that if you have a little bit of water or a whole lot of water, the density is always 1 because it's a proportion. And so if you cut it in half, still the same proportion. Good. Weight, 1 versus 10 pennies, the weight is going to change, so that is extensive. Melting point and boiling point. Doesn't matter how much you have of a substance, the melting and boiling point do not change. It might take longer to melt, but the temperature at which it melts does not change. And then solubility, it's either soluble or not, so I would call that intensive as well. So hopefully you got a hold of that and can understand those and got those right. I hopefully, if you do not, reach out to me. But you do have your quiz on Friday. It's open from 7:30 until 1:30, and it's all about matter. Thank you, guys.